All right, so now that you've had a chance to look at those problems, who can tell me what would complete the square here? 1. And how would this factor? Right? What would complete the square here? 16. And how would this factor? -4, because it has to be, that's the number that you squared, right? What would complete the square here? And you're going to get fractions maybe, right? So you take half of -5, so that's x minus 5 halves. And by the way, Desmos wants to see it as fractions, we learned earlier today. Not Desmos, sorry. WebWork. Yeah, WebWork wants to see it that way. Now, if you square that, what do you get? 25/4. These are equivalent. This is the factored form. Here's the PST. If you take half of 1/4, what's half of 1/4? Yep. So x plus 1/8. That's going to be squared. If you squared the 1/8, what would you get? 1/64. 1/64, right? Yeah, because 1/8 squared, I think what you did is you added, yes, right? Okay, so if we square that, we get 1/64, okay? Now, once you complete the square, you can use that to solve. So let's look at example 3. And we want to solve by completing the square. So here's the thing. Is this a perfect square trinomial right now? You would say, no, it's not. If I subtract 5 from both sides, I'm going to get x squared plus 6x equals -5. So I'm putting that -5 away so that I can figure out what would I need to add here, and I can add that same thing to both sides that would complete the square, because I want to make it into a perfect square trinomial. So we go half of 6 is what? So that means you have x plus 3 squared. When you square that 3, you are going to get a 9, right? So that's our perfect square trinomial, and that's it factored. So once I take half of the 6, I get 3. That's going to be my factored form. If I square it, I get 9. I have to do the same thing to both sides. So I'm adding 9 to both sides. So I get x plus 3 squared equals what? 4. Good. Now, if I want to solve for x, what should I do to solve? I'm going to take the square root of both sides. I get x plus 3 equals plus or minus 2. That means I have x plus 3 equals positive 2 and x plus 3 equals negative 2. Okay? What should I do to get x by itself? I'm going to subtract 3. I get x equals -1. Subtract 3. X equals -5. Okay? I can always check those, -1, -5. So then you would check. Okay? But I would normally have you try these and then we'd share out. We're running a little late on time. So let's go over to the next side. We're going to look at example 5. And we're going to solve by completing the square here. Now notice this one is a little bit trickier because the leading coefficient is not 1. So that's the difference. So if you had a leading coefficient that wasn't 1, I mean in this case these actually all would be divisible by 2. Let's try an example where they're not all divisible by 2. Because see here you could actually divide both sides. Everything could divide by 2, right? Here everything you could start by dividing both sides by 2, and then that would be much easier to complete the square. Let's do this one right here where not everything is necessarily divisible by 2. So the first thing I'm going to do, what should I do you think to set this one up to complete the square? Yes, so I would get that 1 away. So I'm going to add 1 to both sides. I get 2x squared plus 6x equals 1, and I didn't leave enough space actually because I really want my equal sign over here because there's something I need to add here in order to complete the square. So there's a couple of different things we could do. I think before we start completing the square, let's go ahead and factor out the 2. So you could really at this point, maybe I would actually just divide both sides by 2. Divide everything by 2. Yeah, that would get rid of it. Since it's an equation, I can do whatever I want so long as I do the same thing to both sides. So if I have x squared plus 3x plus something, that's how I'm going to complete the square, equals 1/2. And I'm going to add that same thing to both sides. So what would I need to complete this square here? What do I do? Take half of the 3. What's half of 3? 1.5. And actually in WebWork, 1.5, 1.5, same thing. In WebWork, they do want you to have the fraction. So let's leave it as 3/2. 3/2, same thing, right? And that's going to be squared. So if you square the 3/2, what do you get? 3/2 squared would be 9/4. So I'm going to have to add 9/4 to both sides. Does that make sense where I'm at right now? The fact that I'm adding 9/4 to both sides? Ask me if you have questions. Stop me. All right. So now, if I simplify this, I have x plus 3/2 squared equals, what do you have to do to add those fractions? Yeah, 2/4 plus 9/4. I need a common denominator. So I have x plus 3/2 squared equals 9, 10, 11. 11/4. And what should I do to solve for x now? Take the square root. Good. So I'm going to take the square root. Once I have that x squared isolated, or that square term isolated, I can take the square root of both sides. I have x plus 3/2 equals plus or minus. Now I'm going to do some fancy footwork. Square root of 11 over 2. Do you see where I got the 2 from? I'm taking the square root of 4 is 2. So I'm taking the square root of the whole thing, right? I'm taking a square root of 11. I can't. I'm taking the square root of 4, and that's where I got the 2. You can't do anything with square root of 11. It's what we call an irrational number. So since it's not a perfect square, I can't take the square root of it. If I took the square root of it, it would be a decimal that would go on for infinity. It'd be a messy number. So we just leave it, to be more exact, we leave it as a square root of 11. What should I do now to get x by itself? Yes, I'm going to subtract 3/2 from both sides. So I get x equals negative 3/2 plus or minus the square root of 11 over 2. Conveniently for me, they have a common denominator. So this might look familiar to you. Negative 3 plus or minus the square root of 11 over 2. Another way to solve quadratics that we haven't talked about in this class, that was in the prior class, is called the quadratic formula. How many people are familiar with quadratic formula? X equals negative b plus or minus square root b squared minus 4, or whatever. Anyway, you know the song. The point is that if you use the quadratic formula, you would get the same answer, and that's why I left it in this form like this. But this is 2 different solutions because of the plus or minus, right? So that's solving, completing the square in order to solve. And you can also check these, right? Use set notation and check.